All right, so number 61 for warm up. All right, think about it as separate problems, is how I think about it. Okay, I'll write it out over here on the right so we can see it. So think of it as 18/27ths, and then W to the 1/3 up top, and W to the 4/3 on the bottom, and then on the V's, 5/4 and 1/2, right? So just do each problem separately. So what goes into 27 and 18? What number? 9, right?
9.
So what's 18 divided by 9? 2. And what's 27 divided by 9? 3, right? On the W's, what's bigger, 4/3 or 1/3? 4/3. So the W will stay in the bottom. And then what is 4/3 minus 1/3? Just subtracting. 3/3, which is 1. So you can put the 1 up here, but you don't have to. AJ.
So the one on the bottom is bigger than the one on the top.
Exponent, yes. Then that's where that letter or variable will stay. Yes. All right, so V's exponent is bigger, right? So the V will stay in the top. And then what's 5/4 minus 1/2 is how many fourths? 2/4. So what's 5/4 minus 2/4? 3/4. So there's our answer. Does that make sense to you guys?
A lot.
Jordan? Okay, so this is a 4/3. All right, that's bigger than 1/3. So that's why I put the W in the bottom. And then I just subtracted 4/3 minus 1/3 is 3/3. And 3/3 is 1. So we just reduced that fraction. Okay, anything else on that first one? Okay, on 67, the way it looks right now, can I add them?
No.
No, and why not?
They're not the same.
They're not exactly the same radicals, right? It's got to be the same index with the same variable to the same exponent underneath. And then out front, it's got to be like terms as well, right? That makes sense? So first thing I should do for 16 is do my factor tree, right? And like Caleb just said, it's 4, 2. So a 2 comes out, right? For the 16. We'll just go here. All right. Now, how many times does 4 go into 10? Twice, right? So that means that W squared comes out because there's 2 sets of 4 W's, right? How many W's are left over? 2. So underneath the 4th root there, I need a W squared. You with me?
Oh, yeah.
So for the 16, we had 4 2's. That's where that 2 came out. For the W's, I'm looking for groups of 4. There's 2 groups of 4 W's. That took 8 of them, right? So that's why it's W squared that came out. Taylor, you okay? Okay. And then there was 2 W's left over, so that's why I had a W squared underneath. That took care of all 10 W's. You follow? You follow? All right. Here, all I look at is the 6 W's. How many 4's in 6? 1. So when I pull a W out and there's already a W out front, how many total W's in? 2, right? So I've got plus 2W squared again. And then how many W's were left over when I took 4 of them away? 2, right? So are these like radicals now? They are, right? They're exactly the same. So what's 2W squared plus 2W squared? 4W squared, and then fourth root still of w squared. Caitlin, you okay? Any questions on that one? Cool. All right, so let's go over answers to our homework, and any of those that you have a question on, we'll go over. All right, so if I go back up here to the top, we started at 36, right?
Yeah.
This was page 242, 43. All right, 36. Negative 4 times the sixth root of 5, right? All you have to do is subtract 12 from 8, right?
Yeah.
38. 13 minus 4 is 9, right? Times 8 to the 3/4 power. Okay? 40, you have to simplify the 150, and you end up getting 62 times the square root of 6. Everybody need to see 40? You want to see that? Sure. All right. So for the 150, I'm going to go, let's just go 15 times 10. And then 2 and 5, and 5 and 3, right? So since it's square root, I'm just looking for a pair, right? Of 5. So for that pair of 5s, I pull it out, but there was already a 7 there. So I do that 7 and the 5. Multiply. So that's 35. Square root of what was left? 3 and 2. I multiply those. So I got a 27 radical 6 plus 35, and that's a 62 radical 6. 42 is 3 times the cube root of 2. And 44 is 19 times 5 to the 1/4 power, or the 4th root of 5. Either of those, anybody want to see? 42 or 44? 44? Okay. So remember, 1/4 power is this, right? So this is 5 times 81. It's 9 times 9. And then we get the 4 3s. So I can pull a 3 out. There's already a 6 there. So it's 3 times 6 is 18. And then it's 5 left over to the 1/4 power, right? Or 4th root. So then it's 18 plus 5. So it's 23. 5 to the 1/4. Or if you want to write those, if it's easier for you to write it as radicals, 4th roots, you can do that. Now, my book said 19, didn't it? Should be 23, right? Because it's addition. Oh, yeah, 3 times 6 is 18, right? So my book had a wrong answer. I didn't do anything wrong, did I? Sometimes I do. Right? I pull the 3 out, there's already a 6, so it's 6 times 3, right? Yeah. So the answer should be 23. Right? Yeah. So let me fix that in my book. All right. 46, 48, and 50. 46 is 4RT to the second. 48 is K to the 4th over 2Z. And 50 is 1 over n squared p. Any of those you'd like me to go over? 50? Okay. What I like to do first, before I try, since they're both under the radical sign, I try to simplify those first. So the first thing I notice is I have a negative 1 for an exponent. How do we make it a positive 1? Yeah. Yeah. So from the top it goes to the bottom. So this would be n squared over n to the 18th, and then there's nothing left, so that's like a 1, and then I got a p7 and a p1, which is how many total? 8, right? Now look at here. Where's the higher exponent, top or bottom? Bottom. So where's the n going to stay? The bottom. What's 18 minus 2? 16. So this problem, I'll just write it out here. The top is just going to be 1, and the bottom is going to be n to the 16th, p to the 8th. And then I'm taking the 8th root of that. Okay? When 1's there, square root of 1's 1, cube root of 1's 1, 8th root of 1 is 1, right? So the top is 1. And then just divide the exponent by the index. What's 16 divided by 8? 2. And 8 divided by 8? 1. Okay? So remember, negative exponents go from numerators to denominators to make them positive, or from denominators to numerators to make them positive. We want them positive to take care of stuff, right? Or you can think of it like this. Where's the bigger exponent? 7 or negative 1? 7. What's 7 minus a negative 1? 8, right? So you can just do that one too, I guess. Might save you a minute. All right, anything else? 46, 48, or 50? Okay. 56 is 5r s to the third t to the second times the cube root of rt. So the r and the t are under the cube root symbol. 58, this is the numerator, w to the 7th times the 5th root of z to the 2nd over z to the 3rd. 60, 3x times the square root of y. 62, 1/8 x to the 5/4, y to the 9/4, z to the 2/3. You want to look at that last one, 62? Or any of those?
62, right.
Okay. Right, so I'll put this in green up here. Right, so I'm just thinking 7 over 56. Is there a number that goes into both of those? 7, right? What's 7 into 7? 1, 7 into 56? 8, right? All right, x's, I've got 3/4 up top and negative 1/2 in the bottom, right? What's bigger, 3/4 or negative 1/2?
3/4.
3/4. So the x stays in the top. And then what's 3/4, and that's 2/4, right? 1/2. What's 3/4 minus a negative 2/4?
5/4.
5. All right. Y's. What's bigger, 5/2 or 1/4?
5/2.
5/2. How many fourths is 5/2? 10/4, right? Just double the 5. So what's 10/4 minus 1/4?
9/4.
9/4. So the y stayed up top to the 9/4 power. Now z is to a negative 2/3. We don't like that negative exponent, so how do we make it positive? Push it up top. So there's our answer. Anything else? Okay. The last three there. 64. What's 11 minus 5? 6, right? What's 7 plus 3? 10. Jordan?
The one of the 9/4
Okay.
No.
All right, so I made 5 halves, 10/4. This multiplied 2 by 2 and 5 by 2. So I got like denominators. And then I just subtracted 10/4 minus 1/4. All right, 64, 66 were easy, right? 68, we gotta make them the same. But the answer is negative 7p to the third times the cube root of 4p. Do I need to go over that one? I can. We okay?
Yeah.
We're good? All right. So, just taking your time on those, you should be okay. All right? Number, fourth root, you're looking for groups of 4. Fifth root, groups of 5. Cube root, groups of 3. Right? Today I have a practice quiz for you. Do that. Go over it tomorrow. And then the quiz will be Thursday. All right?